Hello, my name is David Foley. I'm CEO at Status Pro, and I would like to tell you something about the SPIoT project today. Essentially, three technologies made this SPIoT concept possible. I'll just rapidly go through them. Starts with the NB-IoT technology, which is called narrowband IoT, the opposite to broadband. The purpose of that is it allows little sensors to be internet participants. Which means they can send data through the telephone network to a server. The second technology effectively comes from a nanotechnology, allowing MIM sensors to be built, and these are low energy, low cost sensors for a variety of physical characteristics like vibration, temperature, humidity, CO2, VOC, and a bunch of other characteristics as well. And the third technology which made it possible is the idea of containers in virtual machines, I think originally developed by Google, which allows individuals to look at their data on an internet site. As I say, it's totally different whether the internet site stays the same for everybody or whether each customer gets to see his data and only his data on the same site. So those three things made SPIoT possible. As we got involved with this, we spoke to a bunch of customers about what their requirements might be for a concept like that. The first people who actually approached us were the electromechanical workshops. These are people who repair motors and pumps and other pieces of machinery for their customers. And they said what they would really like to do is they would like to install a sensor on a motor, for example, deliver to their customer and offer their customer the opportunity that they would keep an eye on this motor without, and that's the important bit, without any installation cost or with any IT cost or activity required on site, because that makes the thing ridiculously expensive then. So that was one customer group. And in this video we're going to have a look at the other customer groups which we spoke to. Then we move essentially to environmental monitoring, where we spoke to people in food transport or food storage. So we're talking about monitoring air conditions like temperature, humidity, pressure, maybe CO2 in a storage facility or a hall. This could be for food, which would have then required alarm temperatures, I don't know, about 6 or 8 degrees or something like that. This took us one step further, where we spoke to the people who were trying to, for example in Germany it's a big deal, who were trying to monitor the current levels of groundwater around the country. And maybe what's particularly interesting about that is you're talking about distributed infrastructure. Groundwater is measured in the middle of nowhere. Today by hand, occasionally. Our interest here is to find a way where we could deliver regular data through the telephone network about groundwater levels throughout the country with a minimum cost. So I guess what connects all these things together is the idea we have minimum installation cost and no IT. Because the system, the idea, you have on the one hand, you have a sensor, which is an internet participant, and then you have a platform which allows us to look at the data. And between those two things, we have a telephone network or some communication technology. Today, in our sensors, we have three technologies at our disposal. We have the NB-IoT network, but we can also connect to wireless LAN or other facilities like that. Okay, the next thing I want to talk about is measuring air quality and temperature in storage facilities. So let's imagine there could be a storage facility for anything. You could be storing boats, old timers, food, air conditioners, and you simply want to know or you want to keep an eye on what is the temperature, maybe the humidity, maybe CO2, maybe air quality in half a dozen positions in your storage facility. So what you got to do, and you want to do that as cheaply and with the minimum amount of hassle and effort possible. So what you do is you install your sensor, you install one of these sensors, and install means you hammer a nail on the wall and you hang it up there, in half a dozen positions around your hall or your storage facility, and they will deliver data to your location in the platform. And if you want, and you have set the alarm limits for be it humidity or temperature, the platform will send you a message to say you're approaching your limit or you have exceeded your limit. And the whole purpose of that is do that with the minimum amount of hassle and the minimum amount of cost. That's I guess the application for storage facilities and halls. And the third aspect we're going to talk about is environmental monitoring. This is a big deal for us. We're currently involved in a couple of projects, but they're still very small potatoes, like planting, using plants on the surface of buildings to see what effect this has for the internal environment in the building and what effect this has for energy costs and things like that. But I'd say it's early days. We'd be very interested in pursuing projects involving measuring of soil humidity, soil movement, river levels, these kind of projects. But of course, we are facilitating somebody who's involved in this and knows this. Remember, what's good about this technology is, or what it's particularly ideal for, is measuring data and returning data in remote areas. All we require is even a lousy telephone net and we'll get the data home. So please come back to us if you think this technology is of interest to or could help in your project. Please get in touch because that's something we want to pursue. Thank you very much.